Okay, welcome to the deep dive, everyone. Today, we're going to be getting into something that's
Yeah,
pretty important in the digital world right now.
absolutely.
Container forensics in the cloud.
Yes.
Basically trying to figure out what happened, who did it, and why when these, slick and efficient containers that we hear so much about
hmm
um, run into trouble in the cloud.
Exactly.
You know what I mean?
Yeah. So containers with Docker, as a really good example,
Yeah.
have become really essential in software development
Mm-hmm.
and deployment these days. I mean, they're
Oh, yeah.
so good for saving resources
Yeah.
and keeping applications all nice and isolated.
Mm-hmm.
But because we're relying on them more and more,
Right.
it also means you really have to understand the security risks
Yeah.
that come with them
Yeah.
and how to investigate thoroughly
Yeah.
when
Yeah.
security's been breached.
Right.
And actually, our research shows a 300% increase
Whoa.
in container-specific attacks just in the last year.
300%.
Yeah.
That's a huge jump.
It is.
That really shows why we need to be talking about this.
Yeah, absolutely.
So, for this deep dive, your mission, if you choose to accept it,
Right?
is to come away understanding how complex container forensics in the cloud is
Yeah.
without feeling like your brain just ran a marathon.
Right.
We've gone through a whole bunch of research
Mhm.
from detailed methodologies
Yes.
to analysis of security platforms
Mhm.
to the challenges that are unique to this and the standards that are evolving.
Absolutely.
We've even got some surprising stuff to explore.
Yeah.
Okay, so let's unpack this a bit.
Sure.
Why do we need container forensics in our toolkit?
Well, the main reason is pretty simple, I guess. The more valuable something is, the more attention it's going to get from
Mhm.
people who want to, exploit it.
Mm-hmm.
So as more sensitive applications and critical data
Right.
are being stored in containers in the cloud,
Yeah.
they become big targets for malicious actors. And container forensics is essentially the detective work.
Okay.
We investigate attacks to figure out what happened,
Right.
analyze the threats,
Yeah.
and ultimately say who's responsible for those attacks.
Okay.
And doing this not only helps us respond to incidents effectively,
Right.
but it also acts as a deterrent.
Interesting.
Because if someone knows their actions can be traced,
Yeah.
they might think twice about doing it in the first place.
That's a really good point about deterrence. It's like having security cameras,
Yes.
their presence alone can make someone think twice.
Exactly.
Now, you mentioned research.
Yes.
How established is this field of container forensics?
Well, this is where it gets interesting.
Okay.
So container technology is everywhere,
Yeah.
but the dedicated research on frameworks
Right.
for investigating security incidents,
Yeah.
specifically in containerized environments, that's still pretty new.
Oh, so we're playing catch up then.
Yeah, kind of.
Okay, so for anyone listening who might not be super familiar with containers, could we get a quick overview?
Of course, yeah.
One of the sources compared it to system virtualization.
Right. Well, think about traditional system virtualization,
Okay.
where you use something like a virtual machine.
Mm-hmm.
What you're doing is creating a complete
Yeah.
independent operating system
Ah.
running on top of your actual hardware.
Okay.
So you've got the kernel and everything.
Right.
But container virtualization, that's way more streamlined.
Okay.
So a Docker container, for example,
Mm-hmm.
is a self-contained lightweight package.
Okay.
It only has what the application needs to run,
Okay.
the code, the runtime, the libraries, the settings.
Okay.
But the key difference is it shares the host operating system's kernel.
So it's more efficient because it's not carrying a whole other operating system around.
Exactly. It's much lighter.
Got it.
By sharing the OS Docker
Mm-hmm.
saves a lot of space
Mm.
and other resources compared to full virtualization.
Okay.
We often call it OS level virtualization.
Okay.
And a key thing here is process isolation.
Right.
Or what we also call sandboxing.
Okay.
This makes sure that each container's processes
Mm-hmm.
are kept separate so they don't interfere with each other
Right.
and with the underlying host system.
That isolation sounds really important for security.
Oh, it is, yeah.
So if we're looking at a typical system, say one based on Ubuntu 16.04.1, like one source mentioned,
Right.
where would we find the core of these containers?
So the default Docker working directory is at varlib docker.
Okay.
That's the main hub
Okay.
for everything Docker related on that system.
Got it.
This directory has all the files and directories needed to
Ah.
build the file system environment
Mm-hmm.
for your Docker containers.
Right.
So that includes the layers that make up the container images
Mm-hmm.
and any data volumes that are mounted into the containers.
Right.
Understanding what's in Varlib Docker is super important for any forensic investigation because
Yeah.
this is often where we find evidence of compromise. It's also where attackers might try to mess with container images
Okay.
or hide malicious files.
Got it.
So it's forensic analysis is key.
Okay. So now we have a good understanding of containers.
Yep.
Let's bring in the cloud aspect.
Okay.
Our sources talked about some unique challenges that cloud environments have for forensics in general.
Right.
How do these challenges specifically affect container forensics?
So a lot of the general challenges in cloud forensics
Okay.
are amplified when we're dealing with containers.
Okay.
One of the main ones is the lack of direct physical access
Right.
to the infrastructure.
Mm-hmm.
Unlike a traditional on-premises environment,
Yeah.
you can't just go and examine the server hardware
Right.
that's running your containers.
Right.
Everything has to be done remotely,
Okay.
relying on the cloud provider for access and information.
So you're at the mercy of the cloud provider's goodwill
Yeah, basic.
and the tools they give you.
Right.
What other hurdles are there?
Well, the dynamic and elastic nature of the cloud is a big one.
Okay.
Containers can be spun up or down super quickly,
Mm-hmm.
scaled automatically based on demand,
Yeah.
and moved between different physical hosts
Right.
without you even knowing about it.
Wow.
So this means that evidence can disappear really fast
Oh, wow.
if you don't have the right processes and tools
Okay.
to capture it quickly.
So it's like trying to photograph a moving target.
Exactly.
Okay.
Then you have the issue of multi-tenancy
Mhm.
and shared resources.
Right.
Your containers are probably running on the same physical hardware
Right.
as containers from other customers,
Yeah.
maybe even your competitors.
Right.
So this makes evidence collection tricky.
Yeah.
How do you make sure you're only accessing your own data
Right.
and not infringing on someone else's privacy?
Yeah.
It also impacts how confidential your investigation can be.
It's like trying to investigate something in a busy apartment building
Yeah.
versus a single family home.
Exactly.
Yeah.
Good analogy.
And I imagine encryption adds another layer of complexity.
Oh, absolutely. Data encryption,
Mm-hmm.
used by both cloud clients and providers,
Right.
adds a major hurdle for investigators.
Okay.
You need the expertise and probably even legal authorization
Right.
to get and use encryption keys
Okay.
to analyze the data.
Right.
On top of that,
Right.
the fact that cloud computing crosses borders
Yeah.
brings in legal and jurisdictional challenges.
Right.
Whose laws apply?
Right.
Who has the authority to demand access to data?
Right.
These questions can get really complicated really quickly.
It sounds like a legal labyrinth. What about logs?
Right.
Those are usually super valuable in investigations, right?
They are, yeah.
So,
But getting and standardizing log files from all these different cloud services can be a real pain.
right.
Different providers have their own ways of logging,
Okay.
different levels of detail,
Mm.
and their own formats.
Right.
One source listed a ton of issues like decentralization, where logs are scattered all over different systems,
Right.
fluctuation in availability and reliability problems
Yeah.
with preserving them long term,
Yeah.
difficulty accessing them,
Right.
the fact that sometimes important logs just don't exist,
Wow.
and even when they do,
Yeah.
they might be in completely different formats.
Oh, wow.
Trying to put together a timeline when your log data is like that
Yeah.
is a huge obstacle.
It's like a detective trying to solve a case where everyone's speaking a different language.
Exactly.
Okay.
And some people only remember bits and pieces of what happened.
Area. That makes sense.
Yeah.
What about the sheer amount of data in the cloud? Does that cause problems?
Definitely, yeah.
Okay.
If you need to do things like image virtual machines
Okay.
that host containers,
Mm-hmm.
the amount of data can create big bandwidth constraints.
Right.
Trying to download huge disk images over the internet
Yeah.
can take forever.
Right.
And then there's timestamp synchronization and event correlation.
Hmm.
When containers are running on different hosts,
Right.
maybe even different regions,
Yeah.
making sure the timestamps on your logs are accurate and in sync
Right.
is essential for figuring out the order of events.
Makes sense.
You really need centralized time servers
Okay.
and common log formats
Yeah.
to make sense of a distributed environment.
Okay. So that's a pretty long list of obstacles.
It is, yeah.
How do we even start to approach container forensics in the cloud?
Right.
Our sources did mention some strategies and frameworks.
They did, yeah. So thankfully, there's been some progress.
Okay. Yeah.
One important approach is to use the APIs,
Right.
the application programming interfaces
Okay.
provided by cloud service providers.
Mm-hmm.
These APIs give us a clear and documented way
Okay.
to collect evidence data programmatically.
Okay.
This has several benefits.
Mm-hmm.
It gives us a formal and accurate method for data retrieval.
Okay.
It means we don't have to rely as much on the CSP's manual involvement with the raw data, and it helps us keep the original evidence intact.
So instead of asking the landlord for grainy security footage,
Right.
you're accessing a professionally managed security system with clear protocols.
Exactly.
That sounds a lot more reliable. What else is being developed?
So another interesting idea is the three-party model for cloud forensics.
Okay.
This model says that responsibility should be divided
Okay.
between forensic agents,
Yeah.
the cloud service providers,
That's right.
and forensic personnel.
Got it.
So the CSP obviously controls the cloud infrastructure
Mm-hmm.
and handles the technical extraction of data.
Right.
The forensic agent, which could be a third-party tool or service,
Okay.
acts as a go-between.
Okay.
It interacts with the CSP to ask for specific data,
Mm-hmm.
and it provides a secure and standardized interface
Okay.
for the forensic personnel to do their analysis.
Right.
This often involves encrypting the data provided by the CSP.
Okay.
So this helps to maintain a clear chain of custody
Right.
and make sure the evidence isn't tampered with.
It's like having a neutral intermediary handle the transfer of sensitive information.
Exactly.
That sounds like a good way to deal with the trust issues and complexities.
It is, yeah.
Are there specific architectures being designed for container forensics?
Yeah, there's one called Contain4 and 6.
Okay.
Its main goal is to provide a framework
Okay.
for collecting evidence, analyzing it, and attributing attacks
Right.
in containerized environments.
Okay.
It recognizes that you need data from inside the container,
Yeah.
but also from the underlying host operating system.
Mm-hmm.
So things like file system snapshots,
Right.
captured network traffic,
Yeah.
and memory dumps.
Right.
It also stresses the importance of dynamic data,
Okay.
like real-time information about the containers,
Okay.
the images they were built from
Mhm.
their network configurations,
Right.
and the storage drivers being used.
So it's looking at the whole ecosystem, not just the isolated container. That makes sense because an attack might start or leave traces outside the container itself.
Exactly.
Our sources also talked about tracing system calls.
Yes, they did.
So what's that about?
It's another interesting technique.
Okay.
It involves tracing the system calls
Right.
of the processes running in a container.
Okay.
System calls are the low-level requests
Mm-hmm.
that applications make to the operating system
Okay.
to do things,
Right. Right.
like reading or writing files, creating network connections, or
Yeah.
managing processes.
Okay.
By looking at the order of these calls,
Mm-hmm.
for example, read, header, which changes the directory
Right.
for, which waits for a child process to change state,
Okay.
right? And stat, which gets file or directory status,
Okay.
you could potentially tell the difference between normal activity and malicious behavior.
Interesting.
To make this work well,
Yeah.
you can build a knowledge base of known attack patterns
Right.
using things like CVEs,
Right.
which are publicly known security flaws, and RPCs, which are a way for different software programs to talk to each other.
Okay.
So by analyzing system calls
Mm-hmm.
and comparing them to known patterns associated with exploiting these CVEs or abusing RPCs,
Yeah.
we can spot malicious activity.
It's like looking at the brushstrokes to see if a painting is real or a fake.
Exactly.
That's a great analogy.
Thanks.
Now, having the right tools is crucial, obviously.
Oh, definitely.
Our sources mention a couple of specific security platforms for containers.
Right.
So tell me about those.
Yeah. So one is called Aqua Container Security Platform.
Okay.
It has a lot of capabilities,
Hmm.
like auditing the security configurations
Right.
of your containerized environments,
Okay.
especially in platforms like Kubernetes.
Okay.
And it helps manage overall security risks.
Got it.
What's really good about it is that it can enforce security policies at multiple levels,
Okay.
and it supports industry standards like DISIS, DIGNIST, and HIPAA.
Right.
So it helps organizations meet compliance requirements.
Right.
You can use it in all sorts of environments, from on-premises data centers to public clouds.
So it's about proactively building a secure environment.
Yeah.
What about the other platform?
That's NuVector.
Okay.
It's also a containerized security platform,
Okay.
which means it runs in containers itself.
Interesting.
It's really good at scanning container images
Okay.
and the underlying platform for known vulnerabilities.
Got it.
It can also filter network communication at layer 7,
Okay.
which is the application layer.
Mm-hmm.
This gives you very precise control over how containers communicate with each other
Okay.
and with the outside world.
Right.
Like Aqua, it offers flexible deployment options,
Okay.
including local or cloud-based Kubernetes clusters.
So it sounds like these platforms offer more specialized security
Yeah.
that's designed for the unique aspects of containers.
Definitely.
Besides these platforms,
Yeah.
what general digital forensic tools are useful in the cloud?
Well, a lot of established digital forensics tools have been updated or have features that work in cloud environments.
Got it.
Tools like Autopsy Blackbag Blacklight and Xways Forensics can analyze evidence from cloud storage and email.
Right.
And then the cloud providers themselves have their own security and logging services,
Right.
like Azure Security Center and AWS CloudTrail.
Okay.
And even more traditional forensic suites like Encase Forensic and Access Data FTK
Right.
also have capabilities for looking at cloud-based data.
So it's a mix of specialized container security tools and more general forensic tools that can handle cloud data.
Exactly.
Now, considering how complex this is and the need for reliable investigations, what role do standards and guidelines play in container forensics?
The standards are super important.
Okay.
They give us a common framework, best practices for handling digital evidence,
Okay.
which ensures that investigations are done reliably and in a way that holds up in court.
Right.
ISO IEC 27037 is a key standard here.
Yep.
It gives us guidelines for identifying, collecting, acquiring,
Right.
and preserving digital evidence.
Okay.
It emphasizes important ideas
Mm-hmm.
like the role of the DEFR, the digital evidence first responder,
Okay.
the need to be able to repeat forensic processes
Right.
so we can verify the findings,
Mm-hmm.
and how crucial it is to keep the evidence safe from tampering.
Right.
It even outlines how to handle different types of digital devices and data,
Okay.
like volatile data like memory and stable data like hard drive contents.
So it's about having a consistent and defensible method.
Yeah,
Are there other relevant standards?
there are, yeah.
Oh, okay.
ISO IEC 27041 is all about making sure the investigative processes themselves are sound
Okay.
and that the methods we use for evaluating and interpreting digital evidence are reliable. It says that we need clear requirements for investigations,
Right.
the right forensic tools chosen based on those requirements,
Okay.
and thorough testing of those tools and processes
Right.
to make sure they produce accurate and reliable results.
Makes sense.
Then there's the NIST Cloud Computing Forensic Reference Architecture, or CCFRA for short.
Got it.
Now, it's not a formal standard like the ISO documents,
Okay.
but it's a useful framework for understanding the forensic challenges
Right.
that are inherent in cloud systems and for coming up with effective ways to deal with them.
So these standards and frameworks were all about bringing order and consistency to a field that could easily get chaotic.
Definitely.
Now let's switch gears a bit.
Okay.
Our sources also pointed out some specific security concerns that are especially relevant in container environments.
Right.
So what are some of those?
One big one is the risk of privilege escalation attacks,
Okay.
because Docker and other container runtimes
Mm-hmm.
often work with root privileges on the host system.
Right.
If an attacker takes control of a container,
Yeah.
they might be able to use those privileges
Right.
to access and control the whole server.
Ah.
This can have a much bigger impact
Right.
than just compromising one container.
Right.
It's really important to follow Docker security best practices
Okay.
and use the principle of least privilege
Right.
to stop this from happening.
Makes sense.
Then there are vulnerabilities in the Docker images themselves
Oh.
and insecure system configurations.
Right.
If a base image you're using has known security flaws,
Mm-hmm.
those vulnerabilities can be exploited in any container you build from it.
Right.
And even a small misconfiguration in how the container is set up
Yeah.
can accidentally create security holes.
So even seemingly small mistakes can have big consequences in the container world.
Oh, yeah, definitely.
Untrusted input is another classic attack vector that's still relevant to containers. If an application in a container doesn't check user input properly,
Right.
it can lead to injection attacks,
Okay.
where a malicious code is injected and run.
Okay.
One source even brought up CVE 2002-25401,
Okay.
which was a vulnerability in the TAR software package.
As an example of how mishandling file permissions during extraction
Okay.
could be used to gain unauthorized access.
Got it.
And you know what a surprisingly common mistake
Okay.
is? Just running containers with root privileges when it's not necessary.
Oh, wow.
If an attacker gets into the container,
Yeah.
this makes the potential damage much worse.
So it's all about applying basic security principles
Yeah.
within the specific context of containers and
Yeah.
being super careful about configuration.
Absolutely.
Okay, so another interesting point that was raised
Yeah.
is accountability in multi-tenant cloud services.
Right.
What role does forensics play in making sure there's accountability?
Well, accountability in this context
Okay.
means that service providers and users
Hmm.
have to manage personal information responsibly
Okay.
and be answerable for any misuse
Right.
in a multi-tenant cloud environment
Yeah.
where lots of users share resources.
Hmm.
Ensuring accountability can be tricky. The idea of a data controller is important here.
Okay.
The data controller, which is often the cloud customer,
Right.
is in charge of monitoring what goes on
Okay.
between the service provider and the tenants
Right.
who are the end users of the service.
Right.
They do this to gather accountability evidence.
Okay.
This evidence could be data, metadata,
Mhm.
or records of operations.
Okay.
It helps to show whether the service provider is meeting its obligations
Yeah.
regarding data protection, privacy, and compliance.
So it's like a digital paper trail
Yeah,
showing who did what with the data.
exactly.
So if something goes wrong, we can
Right.
track it back and see who was responsible.
Right.
And finally, we can't ignore the bigger cybersecurity picture.
Yeah, true.
Our sources mention the growing problem of nation-state threats
Hmm.
and how they might affect container security.
They did, yeah.
So what are your thoughts on that?
Well, this is a really important trend.
Okay.
We're seeing more and more cases where nation-state actors are using tools and tactics
Okay.
that we use to associate with cyber criminals.
Right.
This makes it much harder to say who's behind an attack.
Right.
One of our sources, the Microsoft Digital Defense Report 2024,
Okay.
gave us some insights into how actors from countries
Right.
like Russia, China, Iran, and North Korea
Yeah.
have been targeting IT products and services,
Mm-hmm.
partly to carry out sophisticated supply chain attacks.
Right.
The report gave specific examples,
Okay.
like Iranian actors pretending to be business partners
Yeah.
to get access,
Right.
and Russian actors targeting IT supply chains
Sure.
to infiltrate widely.
So container security and forensics need to be ready
They
to
did.
deal with very advanced and well-funded adversaries.
Absolutely.
It doesn't matter if the initial attacker is a cybercriminal or a nation state.
Right.
The sophistication and resources behind these attacks are getting more serious.
Yeah, they are.
So the stakes are higher, and we constantly need to be ready for more sophisticated attacks. Okay, so we've really gone deep into container forensics in the cloud.
We have.
Let's recap some of the key things we've learned.
Sure.
As more and more people use containers,
Right.
the importance and complexity of investigating security incidents in those environments also increases a lot.
It does.
We talked about the unique challenges of the cloud environment,
Crazy.
from the lack of physical access
Right.
to how quickly data can disappear
Yeah.
and the difficulties of multi-tenancy.
Right.
But we also looked at emerging frameworks,
Mhm.
specialized security platforms made for containers,
Yeah.
and the crucial role that standards and guidelines play in
Yeah.
bringing structure and reliability to this field.
Absolutely.
And we can't forget about the security vulnerabilities that
Yeah.
are especially important in containerized environments, and the worrying trend of nation-state actors
Yeah.
using advanced cyber tactics.
There's a lot to think about.
It is.
Yeah, it's a multifaceted challenge. It is
Yes.
that needs a comprehensive and adaptable approach.
Right.
We need to integrate not just technology,
Yeah.
but also well-defined forensic processes
Right.
and strong collaboration across the whole cybersecurity world.
So as we wrap up this deep dive, here's a final thought for you to ponder.
Okay.
Since container technology and cloud environments are changing so fast, how will the methods and tools for forensic investigation need to evolve in the next few years,
Yeah.
especially to counter these increasingly sophisticated threats?
Right.
This is particularly important because we're seeing more and more use of AI, both by attackers trying to find weaknesses
Yeah.
and by defenders trying to improve security.
It's like an arms race.
It is, yeah.
Right.
What will this mean for keeping data safe during investigations?
Yeah.
What about the legal frameworks we need for accessing data across borders?
Right.
And how can we encourage international cooperation in this
Yeah.
ever-changing environment?
Lots of big questions
There are, yeah,
to think about.
definitely.
Yeah.
Thanks.